I'm going to tell you a little bit about, again, the city itself, mostly about our research areas and our programmes. Before I do, I've got a little short video to show you. The thing I love about engineering is that every day we're trying to solve unsolved problems.
For me, engineering is about providing something that people didn't think they could have, and that really, really good solution that you can make a change in the world.
The world would not be what it is without engineering.
We've been engineering bright futures here in Swansea going back all the way to 1920. But now we're doing this on a brand new campus with brand new facilities. And all of that has projected us to become a top 10 university for engineering research. And we're in a beautiful location, right on the beach in southwest Wales.
Swansea has become a second home for me because I've made friends, I've made mentors.
The community and the atmosphere around the campus is just phenomenal. I felt like a part of it, even just coming on an open day.
In the last couple of years, Swansea University has invested £450 million in this brand new facility at the Bay campus. £10 million of that is just equipment for undergraduate students to have access to.
As the world advances, the university is moving with it. So we're not 20 years behind, we're actually 5 years ahead.
One of the visions of this Bay campus is that we were going to really try and connect academia and industry better than ever before. Since 2008, we've received £120 million worth of research investment. A lot of that's come directly from industry. And the great thing about that is basically industry is telling us what are the state-of-the-art problems they're trying to solve.
The industry links of the course is the strongest part of the curriculum, essentially. Got me to exactly where I am now. So I got a very successful graduate position with a large engineering company. They were very impressed by the sort of things we were doing and how realistic that was to what they'd be looking for.
With Swansea University's industry links and their great course, I wouldn't have had the opportunities that I've got now.
Swansea really does push you to achieve your full potential. Come and have a look around. The atmosphere here is fantastic. You see the facilities, get to meet a few of the lecturers. There's something about Swansea, some magic here that's fantastic.
I've been able to discover myself, and I have so much to give back to the society. It's the brightest future you can ever imagine.
There's not much more I can add to that. I think it sums it up quite perfectly about what we're all about within engineering at Swansea University. To go back, we've got a very, very good EPL football team. It's a beautiful part of the world to live at, much like Indonesia. Relatively small city compared to standards over here, but to me, it's quite a large city of 250,000 people. And it's also a fantastic place to work. And we're involved in some world-leading and internationally excellent research projects. So this is the Bloodhound Supersonic Car project. You can see it behind there. We are literally pushing the boundaries of what man is capable of through engineering. We're delivering a session about this later, but this is a car that next year will reach 1,000 miles per hour, about 1,600 kilometers an hour, setting the world landscape record and smashing the sound barrier. Other sort of areas in which we excel within. This is a house that we built last year in collaboration with Cardiff University, where we've looked at advanced photovoltaic technology to build this house which is completely off the grid and is able to generate, store and use more electricity than the house itself needs. It acts as its own power station, and then the next step is to mass produce this in a cost-effective way that could change a continent and really change the way that people live. Another way that we look at how we engage with the rest of the world, and we very much are a global community, and we're trying to advance that at Swansea University as well. We have Tata Steel on site with us. We also have Rolls-Royce on our campus in one of our technology centres, and we're looking at the advanced materials that are used in gas turbine engines on the Airbus A380 planes. So again, making it more fuel efficient, cost effective, less damaging to the environment, and again, pushing the way in which we were able to engage with the rest of the world. And another key research area that we have is in water process and treatment methods. In particular, desalination techniques. And again, we've set up 3 plants in the Middle East, which is able to take salt water, turn it into drinking water for entire villages. So again, it's changing the way that people live in these communities. So we're at the forefront of these big, impacting research areas. And for all of this, we are top 10 in the UK for our research excellence. So in the previous assessment in 2014, we came out 10th in the UK. 94% of our research is world leading and internationally excellent. 94%. The goal is to increase that for the next assessment. One of my favourite rankings that we have is the research environment that we have at Swansea University is second in the UK. We were beaten only by Cambridge University, and we'll beat them next time. But it means that we are outperforming almost all Russell Group universities across a set of criteria and standards. And these are also key research areas. So we're split up into 3 centres. So we have the Singleton Centre for Computational Engineering, we have a Materials Research Centre, and a Systems and Process Engineering Centre. But within each of these centres, we have hundreds of groups and hundreds of projects. And you can see just a sort of summary of these general areas here. So we have complexity with fluid processing. We focus a lot on nano-health and nanotechnology across a multidisciplinary facet. Water advanced technologies, electronic systems, we've got mathematics and computational sciences, centres for printing and coating, projects to do with manufacturing techniques. So these are sort of key research areas, and we have, of course, then projects at postdoctoral, doctoral and PhD, engineering doctorate, and Masters by Research projects that sit within these general areas. We have set titles, but we also have and welcome speculative applications for research projects that fall within any of our areas of expertise as well. And you may have heard in the video about our industry links. It's a key element of the way in which we are structured. It's how we engage with companies and industry on lots of different levels. So from an employability point of view, we send our students on years in industry and work placements. We have guest lectures and careers fairs with representatives from all of these industries. We have our staff who perform research for and in collaboration with these types of companies as well. And we have an industrial advisement board who actually tell us what we need to be teaching, how it should be taught. That's based on the needs of industry and what they feel graduates should have in terms of the skills and qualities. So everything we do is centred around getting our students and our staff contributing to industry and making money for companies and making a difference to the way in which we live and work. So as mentioned, we're top 10 in the UK. We've got links with industry. Our teaching is excellent. We've got 5-star award in the QS Awards. And our career prospects for our graduates, 94% of graduates are in employment or further research. The university itself is about 18,000 students, and it's about 16% international. Within engineering, we have 3,000 students, and it's about 30% international. And when you throw in the other university and the colleges within the city as well, it's a very multinational, multicultural environment at Swansea. Everyone is nice and friendly and welcoming, and we all talk with strange accents and say hello to everyone as we go past, but we're very much used to international input to our city. That being said as well, a lot of our staff are international from across the world. And these are our general areas. So we offer undergraduate degrees in each of these areas, as well as master's taught programs within each of these areas. And of course, our research sits within multiple areas of these. We are very multidisciplinary. We don't want engineers to be boxed into just civil engineering, just electrical engineering. We want our engineers to be multi-skilled. and more well-rounded. That's what industry wants. So being one college, money moves freely between all of these areas. Staff move freely between all of these areas, and students move freely and touch upon all of these areas as well. They become more well-rounded engineers. And that's typical progression. So students can enter at foundation year, from which they then progress onto their bachelor's programme, and that can be completed within 3 years. They can add a year in industry where they work full-time for one of our industrial partners, and they can get that bachelor's done in 4 years. They could enter directly onto a Master of Engineering programme, add a year in industry on, they can transfer from a bachelor's to a master's. Ultimately, we're very, very flexible. So again, there's lots of movement through the pathways that students can complete based on their needs and their wants, which will, of course, change over 3 or 4 years. And then we've got our postgraduate programmes. We offer 2 main types of master's programmes. There's an MSc, which is taught over 1 year. There'll be 9 months of modules and assessment, and then a final thesis. We offer Master of Science by Research as well, and Masters by Research, where instead of taught modules, it is a 1-year thesis, one large project. So the student knows specifically what area they would like to specialise in and focus. If they have a specific problem or project in mind, they can work on only that for 1 year as well, rather than the more general taught MSc. And from that, there's progression onto PhD, standard 3-year research project, or an engineering doctorate, which lasts over 4 years. It's a doctoral degree over 4 years, which is sponsored by industry. So industry will dictate a specific title, a problem that they need to solve, and will pay the tuition for that student, but also a wage on top of it. And it's typically about £20,000, which is a good stipend there for students. And then you heard the word accreditation thrown around a lot today as well. It's very, very important. I think we've lost that still. So accreditation is very important. If you want chartered status, if you want top jobs with the top money, you need to have a degree that is recognised universally. What it simply means is that all of our degree programmes, and every single one of them, has been scrutinised and assessed by the relevant awarding bodies, which you can see there, as well as enemy professors from other universities who then assess the quality of our programmes. And ultimately you get the thumbs up. The programme is approved and fully accredited for what's taught, how it's assessed, who is teaching it. So all of our programmes are accredited in that respect. And I mentioned it's a beautiful place to live. It's also a hell of a place to work. So just 1 year ago, we moved into a brand new campus, spent £450 million on it. And the environment that we've now created really is world-class for our staff, our partners, and our students. So that was a game of football that we had on the beach on one of our lunch times, and it's just a lecture theatre in the background. We're the only university in the world to have a beach on our campus. We actually own the land. And the focus and the real driver for this new campus is engineering. We have half the campus is just for engineering. We've got 4 buildings there. 2 are for undergraduate teaching, learning and research, and then 2 are pure research for our staff.